Hi, this is the first of the videos for this worksheet, which I'm actually probably going to do in three different sections. It's the multiple choice worksheet for Unit 2. Now, whenever you are doing multiple choice, you will have your data booklet available. I have got the section of the data booklet open for this unit, Unit 2. So you have your data booklet. You're not allowed to use calculators for the multiple choice questions. So this is your main source, but obviously also your knowledge. So when doing multiple choice, we need to read the questions really carefully and note important information in that. So starting with the first one, a skydiver jumped out of an airplane on reaching terminal speed. So there's a very important point, terminal speed. Let me just get the highlighter here. He reached terminal speed of 60 meters per second. She opened her parachute. Which of the following describes her motion after opening her parachute? So we have the idea that we've got terminal speed, so we're going at constant velocity, and then opens the parachute. That would lead to an increase in friction, air friction, which would cause a deacceleration. So which of these would work? Now it says over here she went upwards. Now there is no ways that she's going to go upwards. Sometimes when looking at a camera, that gives because the camera keeps going down, it gives the impression that the skydiver is going upwards. But basically what will happen is that she will slow down and then she'll continue to fall at a new terminal velocity. So she continues to fall, but reached a new terminal velocity of less than 60 meters per second. So this is the correct answer for that one there. She went upwards. That would never happen. That means that she would actually have to, her acceleration, the velocity would have to stop going down altogether, to go up and then go down. Alright, looking at the question 2, the graph is a speed versus time graph for an object that is moving in a straight line. The distance traveled by the object. Now for this you need to realize that the area underneath this curve here, this area over here equals the displacement or the distance, depending on if you're talking about a speed or time graph. So we need to find the area of that. That's going to be 1/2 times 4 times 20, and so obviously that is going to be 40. So we're going to get 40 for that one there. Good. So again, if one doesn't have that basic information of knowing that the area between the line and the time axis is the displacement or the distance, then you wouldn't be able to answer that. So the first two are C and B. Alright, let's go on to the next one here. So the diagram shows a girl attempting but failing to lift a heavy suitcase of weight W. The magnitude of the vertical upward pull of the girl on the suitcase is P, and the magnitude of the vertical reaction of the floor on the suitcase is R. Obviously the W is the weight. So because she fails, but failing, you notice there it says failing, it still means that that suitcase is stationary. So what does that mean? It means that there is no net force acting on that. All the forces are cancelled out. The resultant of all the forces is 0. So we need the situation here that the weight, no, it's a terrible error, I'm sorry, it should be vertically downwards. I'm using this pen on this thing, which isn't, I'm not very good, they're terrible diagrams, but anyway, imagine that these are going directly upwards and downwards. They will actually cancel each other out. So this is the weight over here, this is P plus R here, and that these, because there's no movement, there is no net force, so these must all be balancing each other out. So it must be A is the correct answer for that one. Looking at question 4, an object A and B collide together, they end up joined together and stationary. During the collision, force plus F is exerted on an object A by object B. According to Newton's third law, there will also be. Now, obviously, we need to know what Newton's third law says, which basically says that for every force, there is an equal and opposite reaction force. So if there is a force plus F of A on object A by B, then obviously we're going to have a force in the opposite direction. So the plus will be minus, it will be one of these two, and it will be on A, and because object A, it will be on B because object A, the force exerted on object A, so it's going to be on object B here. So it would be 4A would be the correct one. Good. So again, having your knowledge, reading them, reading the questions carefully is very important. Going on to number 5, where we have a lift is operated by an electric motor. It moves between the 10th floor and the 2nd floor, so it's going down floors at a constant speed. One main energy transformation during this journey is. Now, we have here, as it's going down, we have the energies that's going down it's going to be this one of these two. We're going to have to decide between. There's definitely going to be thermal energy because as it's going down, it must be braking. There must be brakes, and that's friction, and that friction is going to cause energy. So basically, we've got these two over here, and because it's going at a constant velocity, the kinetic energy is remaining the same. You see how it says there it's a constant speed. So your energy due to the kinetic energy is remaining constant, so it's not giving any energy from the kinetic, so it must be D. Electrical energy from the motor is being used to cause that to stop. There is going to be thermal energy. Looking at 6, a communication satellite is moving at a constant speed. Alright, note speed, which is not a vector, in a circular orbit around the Earth. At any given time, the resultant force on the satellite is, well, although it's got a constant speed, it doesn't have a constant velocity because that is changing. There is acceleration. Remember, I'll try and draw sort of a circle here. I'm not very good with this pen. But you've got your constant speed, your velocity going, but it's changing all the time. And there's a force always inwards that's causing that. So it would be equal to the gravitational force on the satellite. So that's what's causing the gravitational force is causing that. And that gravitational force is the only force that's acting on the object. Going on to question 7. A ball initially at rest is dropped in the air from a great height. Great height. So there's probably going to be some friction. Air resistance is not negligible. Which of the following graphs best shows the variation with time t of the acceleration of the ball? So we're looking at it's dropping. So obviously, as it drops, the acceleration has to decrease. And it has to decrease to 0 because at terminal velocity, it is no longer decreasing. So it's basically going to be C and D. Now, the thing is, when it's first accelerating, it accelerates fast. The air friction is not so high there, so it doesn't drop. But as it gets down here, so it would be C would be your correct one. D is not correct. So it doesn't suddenly, in this case over here, you suddenly see that the acceleration comes to an end very quickly. here as it gets close to terminal velocity, where the force difference between air friction and the weight on the object becomes very small, that change in acceleration becomes increasingly less and less as it goes down. Good. Now I'm just going to do one more in this section, and then I will do the others in another video. Sorry, I've gone one too many. This is 8. Here we have the graph below shows the variation with time of the velocity v of an object moving on a straight line. So we've got the velocity, the displacement. Now here we talk about displacement, so the direction matters, and we know that the area in between these is going to, so this area here and this area here, so we're going to have to add it together. Now we're looking at from t0 until t is equal to 6. So from 0 to 4 we're going to get our area there equals, because this is a triangle, a half times 4 times 8, and that is going to be 16. That would be 16 meters. And then we've got this part over here from 4 to 6. So the area of that, I'll call that area 2. We can call this area 1. Is going to equal 1/2 times 2 times, now I'm going to put in -4 because it's a negative velocity there. So that's going to be -4. So when you add the two together, we see that this is negative. This is actually, this object has actually gone in the reverse direction here. So it's actually going backwards along that line. So we add these two together and we get a value of 12. So B is the correct answer there. Good, so that's the first one. I will do another one for the next questions. Thank you very much.